Okay, let's look at our problem. Karen is passing out sets of markers, and there are 44 sets of markers and 27 students total. After passing out the sets to the students, how many sets are left over? So let's really look at what the word problem is asking. It's telling us that there are 44 sets of markers total, and that there are 27 students. And Karen is passing out these sets of markers to 27 students. So after passing out the sets to the students, how many sets are left over? And this is where it tells us that we are going to be subtracting. So let's go ahead and look at what we actually need to put down. We have 44 total sets, and we are subtracting 27 to see how many are left over. So we're going to look at our 10 frames, and we're going to put out 44 of these to represent our 44 sets of markers. That's one 10. We're working on our second 10. This is our third 10. Our fourth 10. And then 4 ones to represent 44 sets of markers. And we are subtracting 27. So if we look at this, we cannot subtract 7 ones from 4 ones. And a common misconception here with students and teachers is teachers normally say, students, you can't subtract 7 from 4, when that's really not correct, because in reality, you can subtract 7 from 4, you just get a negative number. And so a way that we can fix this is saying the correct academic language. So right here, if we were showing our students, we would say we are subtracting 7 ones from 4 ones. And if you look right here, you have 4 ones. We cannot subtract 7 ones from these 4 ones. And so we're going to have to look at our tens place and regroup. So we're going to take a 10 from the 4 tens and we're going to regroup. And now we have 10 ones and our 4 ones from the beginning, and if you add those together, that's 14 ones. Now we can subtract 7 ones from 14 ones, and so we're going to do that. So that's 4, 5, 6, 7. And now we have 5 ones left, 2 ones left, which is 7 ones left. And just to demonstrate this on the board, we took a 10 from the tens place. So we have 3 tens left. And we added those tens over here. So we had 14 minus 7, and we have 7 left over. And so now, of course, we have to look at our tens place. We have 3 tens left, and we have to subtract 2 tens. And so we're going to do that. 1 10, 2 tens. And what we're left over here with is 1 10 left over. And if you can see here, our total sets of markers left over is 17. And you can see right here that's 1 10 and 7 ones. And now I'm going to show you on a number line. So we're going to make our number line, just like a normal clip would. We're going to And now we're going to fill in the blanks. So 1, 2, 3, 4. We're starting with 1. We're going to go to 5. And now we need to look at our original problem. We're looking for 44 because that's the total number of sets of markers we have. So we're going to skip count by 5s to get to 40, and then we're going to count by 1s to get to 44. So we're starting at 1, and we're going to skip count by 5. So 5, 10, 15, 20, 25, 30, 35, 40. And now counting by 1s, 1, 2, 3, 4. So here's our 44. And now we're going to count backwards or subtract 27 sets of markers that went to the students. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. And so that's 16 and 17 is where that tick mark is at. So we have 17 leftover markers. And a lot of students don't realize, we just did a subtraction problem, but we have 17 over here, and we could add 27 to get 44. So a lot of students don't realize that addition and subtraction are actually inversely connected. And I just showed that right here. So our final answer would be 17